Hey, welcome to this video. In this video, we are going to be looking at the basics of trigonometry. We'll look at primary and secondary ratios for an acute angle. We'll also look at commonly used ratios and angles. And then we'll look at the interaction between the ratios of an angle and the actual angle. So really lengths of sides versus what the angle would be. And then at the end, we'll just look quickly at converting between decimal degrees and degree minutes seconds. First off, when we're looking at trigonometry, basically to start with, we're looking at a right triangle. And so this video is strictly about right triangles. And in a right triangle, you have three different angles. So this angle, and this one. And you have also three different sides. And we need to label what each of those are. If it's a right triangle, this little symbol here means that this angle here is 90 degrees. Okay, so if this is 90 degrees, then I can say something about these other two. I know that in a triangle, all three angles must add up to 180. So if this one's already 90, then the other 90 has to be split between those two. So for example, if I know this one's 30, then that one has to be 60. So that's one thing to know about triangles. Also, when you're labeling these triangles, typically we put angle C right here. It doesn't have to be labeled C, but that's typically standard what they have in books. But typically the right angle is labeled C, and the side across from that, so if you go directly across, this side here is labeled side C. So it's always the angle and the side are across from each other. Now these two are sort of critical ones because this longest side of a triangle is known as the hypotenuse. So typically we have the hypotenuse labeled letter C. It doesn't have to be, it's always the longest side, but often it's C. The other letters don't really matter. Let me throw A up here. So if this is angle A, then side A would be over here. Notice angles are capital letters, sides are small letters. So then that means that this has to be side B, and the angle opposite that is angle B. Okay, so there I've got my triangle labeled with all the letters and things for sides and angles. Also, if I know that this is the hypotenuse, then I can also label these other two sides. And we've labeled them, one is adjacent and one is opposite. However, before I can put them as adjacent or opposite, I have to sort of fix one of these angles that I'm going to be looking at in a particular question. So say, for instance, this is the angle that I'm going to use in a particular question. So that's my angle. Then the side over here, it's labeled letter B, but I also call that side opposite. So this side here would be labeled side opposite. That means if this is the hypotenuse, the only other name for a side has to be this one, side adjacent. I need to fix those when I'm solving a question because all the trig ratios are based on opposite, hypotenuse, and adjacent. So if you wanted to take a second just to practice, you can label this triangle. This would be press pause, label it, and then press play and I'll label it with you. Okay, so that's the right angle. So this side over here has to be the hypotenuse. I could label that as angle C and side C. Then let's put an A up here and a B there. That means that this side over here is little letter B. This side down here is little letter A. Now if this is my hypotenuse, I also have to label the adjacent and the opposite sides. To do that though, I have to fix one of the angles. Last time I did this one, let's fix this one. So if this is the angle in question, then this side over here is my opposite side this time, and this side here would be my adjacent side. Okay. All right, so that's labeling triangles. So let's investigate those ratios then. If I take a look at any right triangle, and here I've got three of them, one that ends in the blue, then red, then green. Each of these triangles have a different relationship between the angle, say this angle, and the sides that are opposite, adjacent, and hypotenuse to that particular angle. Like if I were to take this angle and go smaller, notice that the ratio between this side and the other two sides changes. Like this opposite side, if this is my angle in question, this is the opposite side, this opposite side gets smaller and smaller. So the ratio between this side and either the other two sides also has to get smaller. As I make that angle bigger, say up to a 45 or up to a 60, maybe let's go with the 45. It's not exactly 45, but close. If this is a 45-degree angle here, then the ratio between this side and this side have to be the same. If it's 45, then this is a 45. It makes those two sides the same. So the ratio between the opposite side and the adjacent side have to be the same. So when we're looking at any trig ratio, like sine, cos, or tan, what they're looking at is the ratio between two different sides in this triangle. And as I change an angle, that ratio changes. So here are the three major, I guess these over three here are the major or the primary trig ratios. And what they are is, if I'm looking at sine of theta, here's my theta, that the sine of theta is the relationship between the opposite side, that's this one, opposite side, and the hypotenuse, that's the longest side, that's that one. This side over here must be adjacent. Cos is the relationship between the adjacent side and the hypotenuse. And then tan is the relationship between the opposite side and the adjacent side. In this particular question, I threw some numbers in there, so I could actually say what those ratios are. Sine would be the opposite side is 3, over the hypotenuse is 5. The cosine would be the adjacent side, that's this one, 4, over the hypotenuse, which is 5. And the tangent ratio relates the opposite side, 3, over the adjacent side, which is 4. That's supposed to be a 3. Okay, now, if I know what those ratios are, and we'll see later in the video, if I know what the ratios are, I can also determine what that angle is. And that's sort of what we're doing all the time. Where if I know the ratios, figure out the angle. Or if I know an angle and one of the ratios, figure out the other ratio. That's sort of the formula or where we're heading with part of this trig. Now, so those are the primary ratios. The secondary, or often called the reciprocal ratios, are the same except flipped over. Like sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So I would just flip that over. It would be 5 over 3, or find the reciprocal. Cotan, well, I didn't put these in order. Cotan is a reciprocal of tangent, and so it's adjacent over opposite, or 4 over 3. And lastly, the secant is the reciprocal of cosine, so it's going to be 5 over 4. Okay, so those are the reciprocal ratios. Sometimes you deal with those, but typically our calculators, most of our calculators just have sine, cos, and tan on them. They don't have these reciprocal ratios. So typically I'm just dealing with these ratios over here. But I guess it's nice to know those ones. Now sometimes in a question, like this one for example, I have, if this is my angle in question, I have the opposite side. And this is my longest side, so it's the hypotenuse. But I don't have the adjacent side. So to list all my ratios, I could list part of it, I guess. Sine is opposite 4 over 11. Cosine adjacent, I don't know that, over 11. Tangent, opposite, I know is 4. Over adjacent, I don't know that number. Now, if I know two of the ratios, I can use Pythagoras, which you've done in other classes, to figure out what that third ratio would be. So here's Pythagoras right here. C is always the hypotenuse. So 11 squared is equal to a squared. We'll call that a. So 4 squared plus b squared. Okay, if I keep going with that, 11 squared is 121. 4 squared is 16 plus b squared. Solving for b squared, I'd have b squared is equal to 121 minus 16, which is 105, is equal to b squared. Therefore, b is going to be the square root of 105. Okay, square root principle on both sides. So wherever I see a b, or adjacent, I can put in square root of 105. So this would be square root of 105 over 11. This would be 4 over the square root of 105. And I could over here put those down. Now just one little caveat on this. This is just a radical kind of notation. If I have something like 4 over 105, root of 105, the rule is really you're not supposed to have a square root on the bottom. So the textbook, you might see it written differently than this. Just to fix that, what you do is multiply the top and bottom by the same thing, and you multiply it by whatever this is. So root of 105 times the root of 105, the square roots cancel. And so on the bottom, I'm just left with 105, no square roots. And on the top, I have 4 root 105. So that would be this answer expressed a little bit differently without a square root on the bottom. We call that rationalizing the denominator. Okay, now it turns out that the ratios and the sides that we have, that there are some common angles and common ratios that we come up with. So a 30-degree angle, a 45, and a 60-degree angle, they come up, they raise their heads all the time. And so sometimes it's nice to know what those ratios are. So it doesn't matter what the lengths of the sides are for a 30-degree angle, the ratio between the opposite side and the hypotenuse, that's sine, right, is always a half. So if I have a 30-degree angle here, this blue one, if this side here is 4, it's always half of my hypotenuse. My hypotenuse is here, so this hypotenuse would have to be 8. So the ratio between the sides is always a half. For a 45-degree angle, the ratio for the opposite and hypotenuse is always root 2 over 2. 60, root 3 over 2, and you can look at the chart. This chart is used, or these ratios are used enough that it might make sense to memorize that chart. Quick way to memorize it, the sine row, they're always 2 on the bottom. Cos, they're always 2 on the bottom. And then they go from 1, root 2, root 3. Root 3, root 2, root 1. See the progression there? So those first 2 rows, pretty easy to memorize. And then the last one, I don't know, I just have to memorize it. It's root 3 over 3, 1, and root 3. Okay, so let's try some questions where I have to use those ratios and angles to figure out a question. So here I have a question where it says solve for angle A. Here's angle A right there. And they only give me those 2 sides. I could figure out the third side if I want with Pythagoras, but really to solve for any angle, I just need 2 of the sides. And I have 2 of them already. So this side, let's identify what the sides are. So that's the opposite side. This is your hypotenuse. And this side here must be the adjacent side. So what I do is I use whichever ratio works or has an adjacent and a hypotenuse in it. That would be cos. So to solve for that angle, I'm going to go cos of an angle is equal to the adjacent side over the hypotenuse side. I always write the formula down instead of just plugging in the numbers already. So cos of an angle is equal to the adjacent side is 6 over the hypotenuse is 8. Okay, so now I've got an equation here where I have one variable and I can solve for that. The problem with this one is that this one variable, it has that cosine beside it, and unless you've dealt with that before, it's sort of awkward. But what I want to do is get rid of that cos. Now I don't just divide by cos, what I do is the opposite of cos, just like we do with any other equation. So to get rid of this, what I'm going to do is do the opposite, which I call an arc cos. So an arc cos of this side, these 2 things cancel, leaving me with just a theta. But if I arc cos this side, I've got to arc cos that side. So cos minus 1 of 6 over 8. Now take a look on your calculator and look for that symbol, a cos with a minus 1. I'll just do mine here. So that I have to take the arc cos of 6 divided by 8. And my answer for this one comes out to 41.4 degrees. So that angle right there is 41.4 degrees. Solved. Why don't you try one? Try this one, press pause, see if you can solve that one, and why don't we solve this for angle B? So you can solve for angle B and then see what you come up with. Press play after you're done. Okay, so if I'm solving for B, this is opposite over adjacent, so I'm going to use the tan ratio. So tan theta is opposite over adjacent. Okay, so tan theta is equal to the opposite side was 5, adjacent side was 9. So I'm going to arctan both sides. So arctan this of 5 over 9. Calculator, arctan 5 divided 9 is 29.05 degrees. We'll call it 29.1. So the angle 29.1 degrees, that's that angle right there, 29.1 degrees. Okay, good. So that is solving for an angle. We also need to solve for a side. For example, if I'm given an angle and one of the sides, I should be able to solve for either the other two sides using these ratios. Let's pick, I don't know, let's pick this side. We'll call this one x. Okay, so, or maybe it's side C. Let's use a C, a little c. Okay, so I have this angle. I don't know what that side is, but I do know what this side is. That's the adjacent side. And I'm looking for the hypotenuse side. So the two sides that are really in question are the adjacent and hypotenuse. That's the cos ratio. So cos of an angle is equal to the adjacent side over the hypotenuse side. So the cos of 38 degrees is equal to the adjacent side is 15 over what I don't know is c. Now in this case here, c is on the bottom and I have to solve for that. So to solve for c, I need to get it up top. Easiest way to do that is to multiply both sides by a c. When you multiply both sides by a c, these two c's cancel, so I'm left with the equation c times by the cos of 38 degrees is equal to 15. Okay, now I want to get c by itself, so I'm going to divide both sides by cos 38. Okay, so I'll divide this side by cos 38 degrees and divide this side by cos 38 degrees. On this side they cancel. I'm leaving me with a c, and then here I'll have 15 divided by whatever the cos of 38 degrees is. So on the calculator, I'm just going 15 divide cos 38, close my bracket, go 19. So approximately 19. So that side right there is about 19, whatever it is, meters, feet, inches, whatever. Okay, why don't you try one? Let's go for, you need to figure out what this side is, side B. Okay, press pause, try it, and then come back, press play. Okay, angle in question, that's the opposite side. This must be the adjacent side, and that's your hypotenuse. So again, we're going with cosine. So cosine of 30 degrees is equal to the adjacent side, which I don't know, we're calling it B, divided by the hypotenuse, which is 15. Okay, to solve for B, I need to get rid of this 15. So in this case, I'm going to times this side by 15 and times that side by 15. These cancel, so I have 15 times by the cos of 30 is equal to B. Now, cos of 30 is actually on that chart that I had a bit ago, right there. Cos of 30, the exact ratio for that is root 3 over 2. So if I wanted to, I could just go 15 times the cos 30 is root 3 over 2. And so the B, and this would be, I don't know if you'd use that or not, but this would be known as an exact value. So 15 root 3 over 2. If I did this on my calculator, just 15 times the cos of 30, go, it comes out to 12.99, call it 13. So B comes out to 13. This would be an approximate answer. So this one here would be the exact answer. This would be an approximate answer. Notice it's just fluky. If it's a 30 degree, then I can use those exact numbers. If it's 31 or 38, there aren't exact ones that we've memorized for those. Okay, just as a quick little tip, some people get confused whether they use the second or the arc ratio, or whether they actually use the primary ratio. This is just a quick little thing. If you're looking for the angle, you have to use that arc, or the second tan, or second, in this case, cos. If you know the angle here, you don't use the set. You just hit cos 75, and that gives you the answer for that part. Okay, last thing in this section is to look at degree, minutes, seconds, and how to convert between them. So we can describe degrees in decimal degrees like this one, or in something known as degree, minutes, and seconds. And we need to be able to convert back and forth between them. And to convert them, it's just these are seconds, minutes, and then degrees you can think of as being hours. And so to convert between them, it's always a factor of 60. You just sort of have to know how to go about doing that. So say if, yeah, here I've got a question. Oh no, I'll do these two and then you can try those. So decimal degrees. If I have this and I want to convert that to degree, minutes, seconds, then what I have to do is take this little piece of it and times it by 60. So I'm going to say, so this would be 32 degrees, and I'm trying to figure out how many minutes. So I take my 36, and it's a decimal 36, and times that by 60. Let me see what I get. 0.36 times 60 gives me 21.6. So then I'll have 32 degrees and 21.6 minutes. But I want some seconds in there too. So what I do is I'll take that 0.6 off. So I'll have 32 degrees, 21 minutes, and then I'm going to take the 0.6 and times it by 60 to see how many seconds I have. Okay, 0.6 times 60, 36. So this will be 32 degrees, 21 minutes, and this times this, 36 seconds. So this number here and this number here are the same. One's in decimal, one's in DMS. To go the other way, you just do the opposite thing. Start over here. So if I have 69 degrees, 30 minutes, and 20 seconds, I'm going to start with the 20. Instead of timesing by 60, I'm going to divide by 60. So 20 divided by 60 comes out to 0.33, repeating. And what I do is I add that to the 30. So really, I'm going to have 69 degrees and 30.33 repeating minutes. Then I take this one and times it by 60. We're dividing, right? Divided this by 60, gave me that, add to that. Now take this and divide it by 60. So, add 30. Good. So 30.333 divided by 60 equals 0.5055. We'll call it 0.51. So this would be 69.51 degrees. So this and this are the same. Why don't you try a couple? Press pause, try them, then come back. Okay, to convert to degrees, minutes, seconds, I'll take this part and times it by 60. 0.245 times 60. It gives me 14.7. So I have 50 degrees and then 14 minutes. And then that 0.7 part, I have to times it by 62 to figure out how many minutes or seconds it would be. 0.7 times 60, 42. 42 seconds. Okay, to go the other way, take this divided by 60. 22 divided 60 is 0.366. Add that to the 45, so plus 45. And then divide that by 60. So it's going to be 78 degrees and 0.75, 0.76, call it. Whoops. 78.76 degrees. Okay, hopefully that helps you out with Trig basics.